lecturing part yet. We just give further announcements still because I will still have a lecture for the steps and how to make a prescription for diet. So that's why we still need to discuss before we would have that meeting. Okay? So I will still coordinate with Dr. Wood because she might not be available on some Thursdays. So it might happen maybe before we go for the holidays or maybe as an end of the school year that for biochem. So, but we could incorporate it in our vitamins and minerals topics as well. That could happen maybe a few weeks from now, and I'll be lecturing that, so it's just a few weeks. Okay, so before we start, let's pray. Father, we thank you for this time. Please give us the strength and the energy to understand our lessons, be able to apply them someday in the future. But when we are here, let us help us to be diligent, and then also we can also be able to know and learn new things from these topics. Guide us in grace, truth, in Jesus' name we pray. Amen. Okay, so we are now. Did you have a nice mini vacation for the past weeks? No. How was the exam? The block exam? Were you able to finish listening to the lectures, the online lectures? Okay. Not our fault though. But everything discussed was found in our course. So if you have read in advance for the topics, so you will be able to get it. Okay, but let's move on. Okay, so although it's gonna be a bit, it's gonna be a bit maybe it's a new lesson for some, a review for some. Yet you can still, okay, I see you have already your PowerPoint from previous years. No, it's not, it's fine. Actually, this is not, the PowerPoint is not mine, so it's already been for the past years. So I think they downloaded it during when we have our LMS app. So we kind of posted all our LMS there. So it's okay. But again, you need to read your books. Okay? These are just summaries and supplements, and to help you understand what you're gonna read or what you have read if you've read in advance. Okay? So we'll discuss first water and pH. The reason why is because since we're talking about the kidneys, so we want to know just to correlate our topics with what you will be learning in your histology, physiology, okay, anatomy. And part of that, especially in physiology, is understanding how the kidney works. Okay? And furthermore, we'll continue our topics about proteins. Okay? We have lessons about the carbohydrates, and then we went into your, I think you already brushed up a bit about our amino acids, right? And then we went into the main major pathways, so glycolysis, gluconeogenesis, and the Venous phosphate pathway, glycogenesis, okay, glycogenolysis, okay. So I think that was covered. Most of that was covered by Dr. Wood. So even if we had delays in our lectures, it's still your responsibility to read, okay? Since you have already the topics in advance. time management is the key. So that's just one subject among the others. But I know you can do it. Okay? Laban. That's Filipino term for just fight. Okay? Fighting. Alright. So let's now start with understanding water as an ideal biologic solvent. So it says there it's a predominant chemical component of living organisms. I would like to request guys to just the lectern. Thank you. The lectern. Thank you so much. Apologies, your teacher is quite challenged. But to continue, so we have this this important component in our body, the water. Okay? So when you say your water, of course, this is why we base our terms polar and non-polar. So when you say polar, it means that the substances or the substrates will be miscible with water. So because the water in itself has polar covalent bonds. At least they would remember that they have these polar covalent bonds. And a molecule like water then has regions of positive and negative charges, and that's why it's called polar. So that's the reason why you have the term polar. Okay, so we're gonna be focusing on four characteristics of water and why is it that it's an ideal biological solvent. So even in the body, it's very crucial. Okay? How many percentage in the body they are composed of water? 7%. So, right? Even 2/3 of the earth is composed of water. So it's like that. So your body as a whole, 70% of that is water. Okay, so the first one is that we're gonna be talking is water molecules form dipoles. So the strong electronegative oxygen atom in the water molecule would attract your electrons away from the hydrogen EI. So we're gonna look at this one. Oxygen is electronegative. So hydrogen is what? What's the charge of hydrogen? It's positive. So in the rules of chemistry, no? Like charges would repel, unlike charges attract. Okay. So that's why they have what we call as a partial positive charge. And the two unshared electron pairs will constitute a local negative charge. So that's why it's what we call as a dipole. Okay. Because the charges are distributed asymmetrically. And since water is a strong dipole, it gives a high dielectric constant. Okay. Sorry. Since water has a high dielectric constant, so when we say dielectric constant, it's a measure of substances' ability to insulate charges from each other. Okay? And you see here, water is, its constant is E. So that means that the higher the dielectric constant, meaning the higher the polarity of the substance, and greater the ability to stabilize charges. Okay, so remember the periodic table of elements. Okay, we have oxygen, and it's the moon. Sorry. So oxygen has its atomic number, it's 8. Okay. And remember, the atomic number would represent the number of protons on an atom or the element. Okay. So oxygen, you know that it's 8. So you should remember if they draw oxygen, it looks like this, right? And the mass number represents the total number of protons and neutrons it contains. And for you to say that that element is neutral, it has to have the same number of protons and electrons. Okay, so remember this structure. Okay. So I won't have to discuss because that's a bit technical. So another characteristic of water is that it forms what? What's the special bond formation of water? It forms your hydrogen bonds. Are hydrogen bonds strong? They are weakly bonded. Okay. So oxygen atom is capable of forming 2 single bonds with hydrogen. And then water, since it's made up of covalent bonds, then it could also bind to other molecules with hydrogen bonds. Okay? So because hydrogen, remember what's the charge of hydrogen? It's positive. So it readily forms bonds on electronegative atoms. So usually, the favorite of hydrogen would be with oxygen and nitrogen. Okay. So these are the polar bonds, no? And then we take note, hydrogen bonds. So hydrogen readily bonds with your oxygen. So, uncharged but polar molecules like your sugars, okay, they easily dissolve in water because the hydrogen bonds has the stabilizing effect, okay, that is between the hydroxyl groups or the carbonyl oxygen of the sugar and the polar water molecules. Alcohols, aldehydes, ketones, or compounds that would contain your nitrogen-hydrogen bonds will form hydrogen bonds with water molecules. That's why they could tend to be soluble in water. Okay, so remember this structure here. Okay. Even with ethanol. Okay. So in your sugar, they easily dissolve in water. And as I've mentioned, and as you have confirmed, hydrogen bonds are relatively weak and transient. So they said it says that the half-life of that bond is a few microseconds. Okay? And it just takes 4.5 kcal per moles to rupture a hydrogen bond. So another characteristic of water is that it's an excellent nucleophile. Okay? Meaning, when you say nucleophile, it's nucleus loving. It's a molecule or ion that donates. Okay, remember that? Nucleophile donates a pair of electrons to form a new covalent bond. And meaning the electrons are available to be shared when a molecule has a formal negative charge, partial negative, and lone pairs. Whereas take note also, opposite of a nucleophile would be the electrophile or electron-loving. It's a molecule or ion that accepts a pair of electrons to make a new covalent bond. Okay. So, what are the special properties of water? One, as you have read, and it's a cliche now for water, it's the universal solvent. Okay. And it has the highest heat capacity, conduction of heat, and heat of vaporization. And remember, the nice thing about water has this surface tension, okay, the highest surface tension of all liquids. And the only substance occurring naturally in all three phases: solid, liquid, gas. And it's also the medium for bioavailability. So, water is a universal solvent because, again, it dissolves more substances than any other liquid. And this is due to the polarity of each water molecule. And this helps water dissociate ionic compounds, their positive and negative ions. So, except for oil and according to water. Okay. Water has the highest heat capacity and conduction of heat and heat of vaporization. So remember, how many, boiled water, diba? What's the temperature? 100 Celsius. And so, as the motion increases, when we measure the temperature, we'll also measure the motion, the kinetic energy of molecules. And so, if the motion increases, energy is higher, and thus temperature is higher. And water absorbs a great deal of energy before its temperature rises. The hydrogen bonds in water will also allow it to absorb and release heat more slowly than many other substances. And even if water has a small molecular weight, okay, the boiling point is big. And it's also the same again with its freezing point. Okay? And water has highest surface tension of all liquids. So very cohesive because of their polarity. Remember when you tried a simple experiment, you fill the water to its brim, the way it doesn't spill out easily. That's the surface tension for heat. And its property is what we call eurectination. And it has the highest surface tension of all liquids, as I mentioned. So that's the reason why ships float on water, because of that principle. And of course, it's basic knowledge for all of us. It's the only substance that has three phases: solid, liquid, and gas. And for us, water is the medium for bioactivity. So remember, it says here book 60 to 70%, but we are mostly composed of water. It also influences the shape and function of biomolecules, then the medium of biochemical reactions, import and transport for nutrients and waste, and could also be a participant in chemical reactions. Remember hydrolysis, hydrolysis. Okay. So these reactions, water could also be part. So that's why it says here that where there is water, there is life. That's why they think people, scientists want to explore space to find water. But so far, until now, it's only Earth that has that. So water is widely regarded as the matrix of life, which is not just a passive scaffold, but also has many active roles in molecular biology. Okay. So as we're gonna be discussing about proteins, so it's water that has something to do with their 3D shape, as well as their nucleic acids. And enzymes, okay, use water as a substrate or a product, as I mentioned, examples are hydrolysis and other liases. Okay, so how does water interact with other molecules? So remember, molecules, that's why it's the base of the molecule is a water-loving or a water-fearing. So when you say water-loving, you call that your hydrophilic. And if it's water-fearing, you describe it as hydrophilic. But if a molecule has both hydrophilic and hydrophobic parts, you describe it as amphipathic, just like your proteins. Amphoteric, meaning it could act as a base or an acid, like your water. Okay, remember the phospholipid bilayer? Okay, the best example wherein your proteins, okay, would exhibit a hydrophilic and a hydrophobic property. So you could also have your non-covalent bonds like hydrogen, ionic, hydrophobic. The van der Waals forces will contribute to the structure and stability and functional competences of molecules. So okay, remember this, the different bonds. Hydrogen, and then your ionic bonds. I think we covered that, right? Then you have the van der Waals forces, hydrophobic interactions. Hope you still remember these types of bonds. And these forces, like your amphipathic molecules, they tend to fold the hydrophilic parts on their surfaces. Okay, so that's it for water. But we will also be discussing about your pH. Okay, acid base. Okay, so we want to understand your acid base. I think we've covered a bit during when we had your lungs study in the lungs. then we want to, at the end of this lecture, this part, we will be able to understand how acid-base balance circulated by both the lungs and the kidneys. So this is just to give you an idea of how this process works, how the body compensates when there is changes in the pH. Okay? So I want you to focus on this, because most of the bulk of your assessment will be taken from this, and as well as the entrance. Okay? So what's that? Your erythrocytes, okay, inside the blood vessel. So remember, your erythrocytes also your body has buffer systems. Okay, there are changes in the pH, body will compensate, and part of that, you also have your erythrocytes, your proteins. Okay, they also act as buffers. Okay. So, why is it that it's important to measure pH? Okay, remember your enzymes, they are also pH dependent. And it's the pH that will affect the structure and activity of the macromolecules. So that's why if there are changes, the processes in the body will work well. Okay, so that's why these activities or pH is indeed, these enzymes are indeed dependent on pH changes. Okay, so we've mentioned about the amphoteric molecule. Okay, so when we say acid, it's represented by your hydrogen ion. When you say hydrogen ion, it's the one that would accept donate. It would donate the protons. So that's why you call if it's an acid, you would know it's a proton donor. When we go back learning about amino acids, we would know who are these. Remember the side chains? If they are basic, they are acidic. So we know if they donated protons or they accepted protons. So opposite of the acid would be the base. It's represented by your hydroxyl ion, and it accepts the protons. Okay, so that's why you call them your proton acceptors. And pH is the symbol. pH represents the negative log of the hydrogen ion concentration. So water is actually in constant dissociation. So especially when neutral water molecules and the ions they form. Okay? And with water, then you would have this hydronium ion, zero hydroxyl ions. Remember these symbols. So that's why when we say a mole of water is equal to 6.02 times 10 to the third power molecules of water. In 1 liter of water, it's around 55.5 moles. Dissociation constant is represented by your Ka. Okay? The dissociation constant of water is a Kw. So if you're gonna make it into this, to get the dissociation constant of water, so you have your H2O, your hydronium, and multiply it with your hydroxyl ion. So you would get this answer. So still remember just a bit of the rules of multiplying the ones with So in 1 liter water, temperature of 25 degrees Celsius, so you would say that it's around 1 times 10 to the negative 7 moles of hydrogen, and another would be same with your hydroxyl ion. So, and these are just few water molecules that get dissociated. And this constant, the reason why we need to understand or explain those things because it will be used to define if a solution is acidic, neutral, or basic. So, if these solutions have equal concentrations of your hydronium and your hydroxyl, then you would call these our neutral solutions. And if these are on equal portions, then it could be acidic if it's more of the hydronium and basic if it's more of the hydroxyl. So that's why you have this formula here. Okay? So acidic, remember this, hydronium more than, and then the hydroxyl is less than the 1 times 10 to the negative 7 moles. Opposite to that with the basic. Okay? The hydroxyl is more than this hydronium that is less. Okay. So, mentioned about pH. The scale of pH is logarithmic. So, P meaning it's a power of 10 or the power of hydrogen. So, since we're gonna be, if we're gonna look into real numbers, it's gonna be very, very long. So that's why they get used the logarithmic scale. And pH, to get it, it's minus log times your hydronium or minus log times hydrogen ion. So that's why it's described as the negative log of the hydrogen concentration. So remember that pH is what? Negative log of the hydrogen concentration. Okay. So if an acidic solution with 1 times 10 to the negative 4 moles of hydronium will have a pH of 4. If the basic solution with 1 times 10 to the negative 10, then moles of hydronium will have a pH of 10. That's why you would have pH 4 than pH 10. Okay? Because it represents that number, the power. Okay? So what's the neutral number? That's in the body we are slightly 7.4. Okay, or 7.4. Okay. So pH scale, remember this one? This is just a table. So for example, distilled water has a pH of 7. Okay. Ammonia is very basic. How much more is bleach? No? So black coffee, it's slightly acidic. Okay. Urine also as well. Gastric acid has a pH of 1. Okay. So what are weak acids and bases this time? So first, let's understand also the pKa. Right? Remember the dissociation constant? Okay? So it's the negative log of the dissociation constant. And this would represent the measurement of weak acids or bases. That's why pKa is equal to pH. There will be an equal concentration of acid and its conjugate base. Okay, so for example, acetic acid, its conjugate base will be described as acetate. Okay. So a pKa of a weak acid group is defined as the pH at which the protonated and unprotonated species are present in equal concentrations. Equal concentrations. And weak acids only dissociate partially into anions and protons even at low pH. Weak bases will dissociate only partially into anions and protons even at high pH. So we have your carboxyl acids, your carbonates, amino acids or the amines, and then the phosphoric acids or the phosphates. So these are examples of weak acids and bases. So when in drug making, I think the pharmacists here would agree that most drugs are weak acids or weak bases. Why? It's a bit of pharmacists did it. I guess Watson's. We have the order of Watson's here. So, why? What's the application? Why are drugs made into weak acids or weak bases? So that's why it's easy to metabolize. It would defeat the purpose of drugs not working because it's very acidic or very basic. Okay, so that's why it has to be a weak acid or a weak base so that it could easily be absorbed by the body. Okay, so for example, aspirin is a weak acid. That's why aspirin is not it's given to those especially with lesser risk for gastric ulcers. Okay, it causes ulcers for long-term chronic aspirin use. At the stomach, okay, so we're talking about aspirin here. At the stomach, since it's pKa of, it has a pKa of 3.5, the pH of stomach is around 1 to 2. So this drug will be protonated. Okay? So if the drugs are uncharged, they could easily cross cell membranes. And if pH is less than the pKa, then the compound will be protonated. If it's more than the pKa, it's going to be deprotonated. Okay? So some applications of drug. So that's why we have to determine the quantitative relationship of the pH of a solution and the concentration of a weak acid and its conjugate base. So we have the Henderson-Hasselbalch equation. Okay? Mathematics are familiar with this. Okay? Right? But we were taught about the Henderson-Hasselbalch equation. You will even have to compute. Okay? Now, what did you compute na? Just remember lang the principle. Okay? So pH is equal to the pKa plus the log over the acid. A log times the acid divided by log of conjugate base. Okay? Are you still here with me? It's a bit of a boring lecture, and this is technical. Okay? But you have to understand the principles here. So when we calculate the pH of a buffer composed of 0.1 mole of acetic acid, okay, and the 0.6 mole of acetate, knowing that the dissociation constant is 1.8 times 10 to the negative 5. So first figure the variables. Diba? When we do problem solving in math, we will write down the variables. So we know that acetic acid, diba? HA, so that is 0.1. The acetate is 0.6. Dissociation constant is 1.8 times 10 to the minus 5. So take note of how would you compute first for the pKa. Okay? Remember, you need to get the pKa, so it's the logarithm of the minus log of the dissociation constant. So you have the dissociation constant, so it's easy to compute. So the answer there will be 4.7. You can double check it if you have scientific calculators. So step 2, okay? What are the things we need for that Anderson Hasselbalch calculation? So we already completed for the pKa. That's 4.7. Then plus log. So we have the acetate 0.6 over the acetic acid relation. So if you compute that, what will you get? What will you get? 5 point. There. So you get your 5.48. So that's the pH of your acetic acid. Okay. So now let's go deeper. These are going to be clinical examples. We will be now discussing how the kidneys and your lungs compensate if there are changes in the pH. So there are conditions that would cause changes in the pH in the body. So we have conditions like your acidosis and your alkalosis in the blood. Okay? So what are the two classifications for acidosis and alkalosis? They could be either metabolic or respiratory. Okay? So to compensate that, our body will not just give up easily. So we have so many different buffer systems, and the major organs or organ systems that would play a role would be your lungs and your kidneys. So let's just discuss the anion gap and the buffers in the body. So remember, weak acid solutions and their salts buffer changes in the pH. When we say buffer, okay, it's a compound or solution that has the ability to resist a change in pH. Okay? So if there is the buffer, the pH change could not just be drastic. So when, especially if we add an addition of a strong acid or a base, okay, so the pH will change right away because there is a buffer. So the major or the biologic buffers in our body will be the bicarbonate, okay, the organophosphates, and then your proteins. Okay. And a solution of a weak acid that is conjugate base buffers most effectively if the pH range is at around pKa plus minus 1 pH. So remember, for medtechs, you were asked to compute the pKa about even certain proteins, no? Because why? Proteins have that. What is the property of proteins? They are okay. Anion gap. Okay. So the reason we need to compute for anion gap, especially in disease states, because of its the clinical indication. Okay. So for example, just remember, if it's HAGMA or high anion gap, So it would cause a condition called metabolic acidosis. So that's why we have this mnemonic GOLD mark. Gold meaning glycals, G, oxoproline, okay, so, like for example, taking or those taking paracetamol, excessive paracetamol, lactate, so lactic acid, then your D-lactate is produced by bacteria, methanol, okay, those who just methanol, aspirin, ketones, renal failure, and then your ketones, especially in patients who are diabetic or alcoholic or there is starvation ketosis. So before, metformin was suspected to cause metabolic acidosis, but induce lactic acidosis. Yet it still with studies that it defeats the purpose, or it's not. Metformin is not the cause of lactic acidosis. So how do we get your iron gap? So we need your sodium minus the chloride plus the bicarbonate. So if it's high, it means it's high. And if it's normal, within the range, then it's described as normal. So what's the reference range for an iron gap? Medtex. What's the normal reference range for your iron gap? In what? It's okay. What's the normal range? Yeah, what have you googled? Hey, this is an open books. So it's with max. It's max per liter. Okay. So yeah, it's around like that. 12 to 16. So actually, it's like if it's more than 20, that's enough. Okay. So what are the other buffers? So remember, your enzymes are very sensitive to pH. So that's why there are different pH gradients across the compartments. Okay? So there is a really close regulation for intracellular pH. So if you can see here in this picture, so you would note that mitochondria, the proteasomes, they're kind of basic, no? Then the secretory granules are acidic, even the Golgi network. Then the nucleus is slightly basic. And then you have the lysosomes. It's expected that this would be acidic. Okay. They contain enzymes that are related with this, with acidic pH. Then the cytosol, it's a bit also a bit neutral or slightly basic. It's more of neutral. Okay. So one major buffer system of your body is your bicarbonate and carbonic acid buffering system. Okay? I'll just stay here na lang. My ears are healing. Okay. So, remember this formula or this process. This happens both in the lungs and the kidneys. So, when you say your carbonic acid here, okay, this is your carbonic acid. So it's now the weak acid and then the conjugate base would be your bicarbonate. Okay? So remember that CO2 plus water would be interchanged with your bicarbonic acid. Then its conjugate base would be bicarbonate. Then you have the hydrogen ion. Okay, that's your bicarbonate carbonic acid buffering system. Okay, remember that process, ha? What's the enzyme really? Your carbonic anhydrase. So the one responsible for the interchange. Okay. So these are the interactions that you would see. I'm not sure if this would show. So since the body has buffer systems, these are the ones that would, even with adjustments in the pH, you can still, your body is still able to work well because of this. So remember, we discussed during our respiratory system, we discussed hemoglobin and myoglobin. Remember hemoglobin, it's role as well as a buffer system. And when there is already gas exchange, okay, remember that? So, the respiratory tract can actually adjust the pH in just within minutes when we exhale carbon dioxide from the body. And then the renal system will also, you're gonna see in the lower part, can also adjust blood pH by excreting hydrogen ions. Okay. And will conserve bicarbonate. So these are in the process of acidosis. No? And in the plasma, you have your proteins, you have your phosphates, and even the bicarbonate and carbonic acid buffers. So again, respiratory, their control is in carbon. How would they do? They will exhale carbon dioxide. In the kidneys, what they do? What the body will do? They will excrete hydrogen. Okay. So when hydrogen is excreted in the kidneys, it will generate your bicarbonate. That's why the pH, the plasma pH is maintained. The protein buffers, on the other hand, would be in the intracellular function. Okay. So all of these proteins could act really as buffers, especially if they contain, remember, your charged amino acids. Okay. So in the blood, that's why one of the component of our buffering mechanism would be in the blood. Okay? If our blood doesn't know how to buffer, we would be dead already. Okay? So again, remember the role of hemoglobin. So how about phosphates? So phosphates are found in the blood in two forms. So you have the sodium dihydrogen phosphate. That's the weak acid, acts as a weak acid. Then the sodium monohydrogen phosphate will act as a weak base. So when your sodium dihydrogen phosphate will come in contact with a strong acid like hydrochloric acid, so the base picks up a second hydrogen ion. Then it will form the weak acid and sodium chloride. Okay. So how is the body able to so take note of this pathophysiology. Okay. So if there is a disturbance of the acid-base homeostasis, okay. So remember, let's focus on acidosis. When we say acidosis, the pH is low. Okay. So what happens there? It will again your CNS will be stimulated, and even the major blood vessels, okay, the receptors, especially in the arteries, and it will increase the respiratory rate. Remember, what's the role? Why there is increase in respiratory rate? So that CO2 will be excreted, and your carbonic acid would decrease. Okay. And then the resulting mechanism, pH will increase. So it would restore the homeostasis. Now, when there is an alkalosis, okay, what happens there? Okay. Again, brain receptors, arterial receptors will be stimulated. It will decrease your respiratory rate. Why? Because you want to preserve CO2 and carbonic acid. So that's why your pH would decrease and you go back to your normal homeostasis. So that's the basic understanding of how your acidosis or alkalosis works. To classify it into metabolic and respiratory is another story. So you're not there yet. So let's just focus now on the basics. So remember this event in the lungs. Okay, when hemoglobin comes in contact with your remember hemoglobin comes in contact with the alveoli. It's not really hemoglobin, it comes in contact, it's the capillaries, diba? So there is the changes of CO2 being excreted, okay, and O2 is being received by hemoglobin. And because of that, you would have that compensatory mechanism of achieving or maintaining the homeostasis, the acid-base homeostasis of the body. So, for renal regulation, usually in the respiratory, it would address the respiratory component. If it's in the kidneys, it addresses the metabolic component of the buffering system. So, with respiratory system, especially the breathing centers in the brain, will control the levels of your carbonic acid. Well, because CO2 is also controlled. Exhalation of CO2 is also controlled. But it's the renal system that will control the blood levels of your bicarbonate. Okay? So a decrease of the blood bicarbonate can then result in inhibiting your enzyme. What's the enzyme again? Your carbonic anhydrase. So especially if there are patients who are taking diuretics. What are diuretics? These are drugs that will increase what? Urine flow. Okay? So we usually give diuretics in cases of heart edema, okay? Like heart failure or pulmonary congestion. Those are cases you would want to get all the excess fluid out. So patients also has chronic adrenal insufficiency, such as your Addison's disease, will also have a lower bicarbonate level. Or patients with renal damage in general. And bicarbonate could also be low if what? If there is the presence of too much acid, like for example, ketones in diabetic patients who have uncontrolled blood sugar. Okay? And also, you will now have this conversion. Okay? So what's the first step? So remember, take note of the parts there when you study the kidneys ka. So this is the blood, no? Then you have the different, remember, are you in histo na? You started histo na. So what are the different types of the kidney? We have the glomerulus. What's the functional unit galit? Nephron. So what is composed of the nephron na? Glomerulus. Then you have the proximal, distal. Proximal, and then you have the descending loop, then the ascending loop, distal, then the collecting tubules. Okay. So usually the changes happen in the proximal tubules, no? So remember the basic structure, the bloodstream, then you have the cell, and then this is the lumen of the proximal tubule. Okay. So if ever there are changes in the blood, for example, low bicarbonate, so to preserve bicarbonate, so syempre, you have the different changes. You have the transporter mechanisms, no? Are exchange. So sodium, in exchange for sodium, you have hydrogen. And then there is the conversion of your carbonic acid with the help of carbonic anhydrase enzyme. It would break it down. Then CO2 would be transported back to the proximal tubule cell. Then still the same, carbonic anhydrase enzyme would form your carbonic acid, and then would break down your carbonic acid, and then bicarbonate is reabsorbed back to the bloodstream, and hydrogen is excreted. So it would compensate the acidosis. Okay? So vice versa na. Okay? So just remember that. Okay? How it works. Sometimes I might give a case now. 35-year-old diabetic, something like that. Okay, the question is, something like that. Okay. So that's it for our lesson. Next week we're gonna talk about the metabolism of proteins. Okay? Yes. Very happy sila. Okay, so wait. We're not done yet. I just said that your lessons ends there so that you can digest the proteins in your body. Sige, let's continue. Okay, for the SGD group, where are you? Okay, we'll discuss both cases after this, 2 minutes after this. We can stay here if you like. Okay. Or you have a room now. If there's a room, I guess stay here. Okay. Once again, we'll still reschedule our workout, our coaching guard event. Because of the typhoon, so we did not anticipate the typhoon. And again, we have another typhoon coming. It's already there. Oh, you're all adults now. You're so noisy. You will be tagged as a noisy batch from first years. They're very sabaan. Sige. -10 now. Okay, we're not that friendly, but you be expected to be responsible, okay? So, were you quiet last Tuesday? Depressed? Uy? No. No time for depression. It's time for hey, if you are struggling or if you want someone to help you, just reach out, okay? Okay? Depression is no joke. Okay, so your coverage for the assessment will focus on this topic. So it's gonna be just to go to 20 items so that you just this is just a short topic. So that you won't you can focus on other subjects. Then you can easily apply it on your visual and your history. Okay? Pointers, how to approach your kidneys. Okay? How to study the kidneys. Visual-wise, look at the glomerulus. Okay? What are the components that will go in the glomerulus? What electrolytes? Okay? How does it function? What are the active transport mechanisms or the passive mechanisms, filtration mechanisms? Okay? Which one goes back to the bloodstream? What is the role of the arteries? No? The afferent and afferent arterioles. Okay? That's for the visual. Then when you go to the proximal, take note also who are the highlights there. Who were readily absorbed or secreted. Okay, reabsorbed and secreted, diba? Those are the terms you want to remember. So which one is secreted? When you say secreted, that means it goes to the urine, the ultrafiltrate, no? If it's reabsorbed, that means it goes back to the bloodstream. Okay. So remember the components, the mechanism, the transport mechanisms again, diba? Physiology is about like that. Right? Then, transport mechanisms, when I say transport mechanisms, active, passive, okay, or facilitated fusion, okay, which one requires energy or not, which one has a co-transport mechanism, which one is a syn-porter or an anti-porter, okay, remember those? What else? So when you go to the descending loop, which one is not permitted? Which one is not reabsorbed or which one is not secreted? Okay? So remember those things. Then when you go to the distal, what are the hormones? What are the hormones that will play a role? Okay? And then collecting tubules as well. Okay? So you will be you need to draw a diagram. Okay? Draw the nephron. Then place all the notes or the things that is found in each specific site of the nephron. Histo, the different cells, description of the cells. So which one is close to the glomerulus? Okay. Which cell uses such hormone? Okay. How is the proximal differentiated from a distal, from the loop? Okay, talking about the cells, histo, collecting tubules. Okay, what are the differences? What is the differences between nephron and the cortex, and then at the medulla? Okay, there's a difference. Where do you find your basaracta? Okay, so easy peasy. So that's how you approach it. Anatomy, just basic. Supply, blood supply, location. Okay? It's just a kidney bean shape, di ba? You would also include the adrenals, right? It's the same principle we have on adrenals, the different layers in the adrenals, especially sa histo. Okay? So which hormones are produced, di ba? But usually it's in the end of treatment. We discussed that again. So, however, in anatomy, just know the supply, veins associated, and the diseases. Your book has clinical correlations with them as well. Okay? So, right now in anatomy, what are the parts for anatomy? There are no muscles, back, lower back. The bladder, yeah, definitely. So same word with histo. The Ureter, what's the epithelium for ureter? Okay, the dome shape, diba? Diba, it's when if there is urine, diba, it changes shape. That's why it's called your transitional. Yes. The nerve supply of the ureter, the urinary bladder, the sympathetic and the parasympathetic actions. So, if the sphincter, diba, is open or relaxes or is contracts or relaxes. So, those are pointers, and all you need to do is summarize them. When you read, start taking down notes. Don't trust the PowerPoint. Okay? You still have time to go over your books. If you've listened to the lectures well and have highlighted the pointers, it's easy. When you study, you can trace what you need to read on it. Okay? So that's why I've always been saying, study smart. Okay? Don't highlight everything. Which I think that's what you've been doing. Okay? The different colors are. Right now, before the bookstores have shortage of highlighters. Right now, they no highlighters now because it's all in the gadgets. But you're still highlighting everything. Don't do that. During lectures, with your teachers, you need to write down notes. You listen. Even if you're sleepy. I remember I was writing notes. When I woke up, I cannot understand my penmanship. But anyways, the point is, just take down notes. You will remember that really. Back on your long term or then your short terms. Do not ever cram for the exams. And sleep well prior, ha? Remember, always take a bath, please. Okay? Who has tried late to the exams and did not take a bath? So again, hygiene. Be fresh. When you take a bath, you will feel fresh. Don't worry about you read for the night won't go away. Okay? So it will refresh you when you have a good sleep prior to the exams. Okay, what else? If you are sick, get a checkup. Do not overuse your body. Okay? And have a short time for leisure activities as well. Okay? Just to balance things. Netflix episode, what episode are you now? Episode 16. Okay. Sige. If it's a Friday, during your time, or Fridays after class, you will go out, you go for your road game. But Tuesday, good. That's a good one. Have a party after Tuesday. Okay? It's required. Or binge movie watching. I was not introduced to the K-drama world. I was introduced to that during my third year. And during our time, we would watch movies second floor. It wasn't strict that time. So we would watch, finish the episode, season 4 of Attack on Titans. Anyways, that's just yes, I know it's okay, so I guess I think you're now relaxed. So tonight it's not no time Right? And get ready for tomorrow's lessons as well. Okay? Okay. See you next week. Bye.